Today we're going to look at the mole concept in a useful way. In a useful way. Because the thing you need to know, the only thing you need to know is 1 mole of any atom weighs its atomic weight in grams. And we're going to just write a few examples before we do the iron example. We could say 1 mole of oxygen is the same thing as saying, no, let's not pick oxygen. Why would I immediately jump to something that has a 2? Let's say 1 mole of boron, B. How much does a mole of boron weigh? 10.81, and it would weigh 10.81 grams. Does that make sense? And this is just a ratio. Have you guys learned ratios in math? That sometimes we write ratios as fractions? No, what is that? B? Yeah, B, because it's boron. And don't worry, I'll put that there.
You not spell the whole word.
You could if you wanted to. When we use these little subscripts to say what we're talking about, it's for your benefit. It's so you know when you look back at your math what you were talking about. And usually in chemistry, we'll just put chemical symbols there. But if you want to put boron, you could. You could put one. You could, if you felt like it, say 1 mole of boron, an atom, if you wanted to. But that would be clumsy and long. Does that make sense? Yes. What does 1 mole of, copper weigh?
63.546.
Yeah. The other thing we could say is this, that this ratio, it doesn't matter if you say 1 mole of copper is 63.546 grams of copper, or if we say it the other way around. I'm going to write one on here, and you're going to tell me what it is. 4.00 grams of something is 1 mole of something. What element am I talking about?
Helium.
Helium, very good. So with dimensional analysis, we always say that we express things as ratios. And this is a thing we do in math too. If we want to say 2 things are the same, or 2 things are in a ratio with each other, sometimes we can write it as a sentence, but sometimes it's easier just to say like, oh, these 2 things are in a ratio with each other. 4 grams of helium and 1 mole of helium. Those are a ratio. Now, this question doesn't ask about helium or copper or boron. It asks about iron. And so we can say the molecular weight of iron is what again? Let's look here. 55.845, right? Yeah. And yeah, does you guys just say 8? I'll put 845. And usually in the past, we've said atomic mass units, right? We're never going to say that again, even though it's true, because now we're going to behave like chemists. And chemists don't care how much an atom weighs if they're lab chemists. Does that make sense? Theoretical chemists care about that. So we're going to say, actually, there's that many grams in a single mole. And so you can either write it that way, there's nothing wrong with that, or we could say the molar mass of iron, and we can write it as that ratio, as that fraction, is 55.845 grams in 1 mole. These are both saying the same thing. In terms of if I ask you to write down the molecular weight, write it either way. Usually people go this way because it's quicker. But when we go to work with it, understanding that it's a fraction, understanding that it's just a relationship is useful. So let's do some dimensional analysis. All of this is just set up. Now let's do the question. And the question asks, if I have 3.46 moles of iron, how much does that weigh? And so take your time. If I said to you in the lab, okay, today we're going to work with iron, and the recipe we're working with calls for 3.46 moles. Now, first of all, if we're looking at a balanced chemical equation, I could never normally put a decimal in it, right? Because we've always thought of chemical equations as being individual atoms, right? And what's 0.46 of an atom? Doesn't mean anything, right? But now that we're going to talk about moles, where we're talking about big groups of atoms, now if you want to scale a recipe so it's got a decimal, that's totally fine, right? Does that make sense? So now you can scale recipes however you want. which means you can even scale recipes to have big, ugly, stupid numbers, like 3.46. Does that make sense? That's fine. If I made you a recipe that says what we need is 3.46 moles of iron to react with, I don't know, 1.23 moles of copper, that's fine. You could figure all those weights out. Does that make sense? Just remember that the mole is what we need to do chemistry on paper, right? Because balanced chemical equations all work with moles, and we'll get more into that in later days, but mass is what we use to do chemistry on the bench. You don't have to write that if you don't want to. It might even make your paper messier and more confusing. But that's the basic idea, is when we talk about going from moles to mass, what we're saying is when we did the moles, that was working out the recipe. That was working out how the atoms were going to interact. Oh, one of these is going to bump into two of those. And then when we turn it into grams, we're saying, okay, now let's go in the back and do it on the bench and actually do some chemistry. On Monday, you're going to do your next lab, and your next lab is going to be a really simple one. I'm going to give you one of the chemicals that's on the back shelf back there. Everyone's doing a different one. And I'm going to tell you how many moles I need. And your job is just going to be to go get it, read its safety sheet to make sure that you know how to handle it safely, and then to figure out, based on how many moles I told you I needed, how many grams you need to weigh out, and then you're going to weigh it out and bring it to me, and I'm going to weigh it and see how you did. Does that make sense? That's going to be your lab. Nice, easy lab, right? So let's practice here. If I went and said, hey, you need to go get some iron filings and I need 3.46 moles, well, we're going to have to do some math. But again, in chemistry class, I never want you to find the math intimidating because we're not doing equations, we're not doing formulas. And listen, can I show you, when I was in high school, put away or I'll take it. Pay attention to me. I'm an egomaniac. That's the one thing you missed. Neither of you was remotely narcissistic enough.
Well,
You really have to be horribly offended if anyone is paying attention to anything other than you. That's the trick to being me. You have to assume that you are the center of the universe and everything revolves around you, which makes physics harder. Because you're like, shouldn't you calculate the solar system as orbiting around the sun? And I'm like, oh no, my friend, it all orbits around me and things just get weird. The bench. And that's, by the way, do you guys, because when you actually think about it, lab bench is such a stupid term because it's not a bench, it's a table. Normally we think of benches as something we sit on, right? But you know what they call those? They don't call them tables, they call them benches. I don't know why. And it's funny, it's one of those things where I've been saying that so long that it doesn't even occur to me that that's a stupid use of that word, but that's what we call it. We call them lab benches.
It kind of reminds me of this Instagram I saw where it's a bench that has springs on the bottom, right?
Yeah.
So every time someone sits on it, it starts to go back. And at the end, 4 guys sat on it, and they were just leaning back and forth.
That's really funny. You, put away. Unless you're texting somebody to say, hey, I'm hoping Orlando comes and beats me senseless right now, that you can then follow up with oh, he did, put it away. All right. Because this is important. This is honestly, this is the thing we're going to do the most in this entire course. It's the single most important concept. So you might as well pay attention. All right? Pay attention to one thing I say this year, and I hope you do. This is actually probably the biggest one. When we do dimensional analysis, we just write down what we have. So we say 3.46. I'm not going to write the whole word mole. God, that would be so long. I'm going to use the short form. What's that again, by the way? MOL. Yeah. Oh, I saved so much time. And then I always want to mention what I'm talking about. So 3.46 moles of iron, which is Fe. Okay. That's what we're given. And then anytime we do math in this course, I'm going to write down what I'm starting with, and then what am I immediately going to do? I'm going to multiply, and I'm going to make a fraction line. Okay? Good. And then we're going to pause. All right? This is the thing with this course. We don't do formulas. By the way, when I took this crap in high school, and still the way some teachers use it, you want to know what the formula is for what we're learning today? Oh, just wait for it. It's wonderful. N equals M over M. That's the actual formula. N, M over M. Oh, but one of them's small, one of them's big. That's number of moles, that's mass, that's molecular weight. And then you have to do algebra to rearrange it if you're trying to solve for the mass instead. We don't do any of that crap. Does that make sense? Instead, we just talk our way through it. We say, okay, I've got 3.46 moles. And then I say, and I want you to get in the habit of saying this out loud if you need to, in your head if you don't want to seem like a crazy person, if you don't want to seem like that guy in track pants at the back of the bus who's talking to himself all day. I've resigned myself to the fact that that's where I'm ending up. But in the meantime, we say 3.46 moles of iron, and then look at me. And then we say, oh, but wait, I don't want to talk about moles of iron anymore. And that's what I say to myself every time. Like literally I say, but that's not what I want to talk about. That's not the unit I care about now. So then I say, well, where do I put that unit? We put it on the bottom. Do I put numbers yet? No numbers yet. I just put the bottom here and I say, okay, I don't want to talk about moles of iron. And I look at the question. I say, what does the question ask me? Well, in this case, it asked me was the mass. So instead of moles of iron, I'm going to talk about grams of iron. And then the number we put in here has to be a fact. It has to be true. And it's not about our question. Here's what I'm not putting down here. I'm not putting 3.6 moles of iron because I don't know how many grams 3.46 moles of iron is yet, right? That's in fact what I'm trying to figure out. I have to fill these fractions in with something I already know. Does that make sense? And I don't already know how many grams 3.46 moles are, but the periodic table tells me how many grams there are in 1 mole. Does that make sense? When you look at the periodic table, it is telling you, oh, a single iron atom weighs 55.845 atomic mass units. That means that a mole of iron will weigh 55.845 grams. That makes sense? So, if the teacher had told me to go get 1 mole of iron, I would weigh out, I just forgot the number again, is it 55.345? No, 845? Yes, 845. 55.845 grams. Now, the teacher didn't tell me to weigh out 1 mole. He told me to weigh out 3.46. And then, here's a beautiful thing again. You don't have to be great at math to know this. You don't have to be great at math at all. In fact, the calculator is going to do most of the math. We just have to do the thinking for it. So before you punch it in, what I want to show you is this. The reason this works is that it has to work. Because if you take anything, even a unit, if we take moles of iron and divide it by itself, what does anything divided by itself equal? 1. 2 divided by 2 is 1. 8 divided by 8 is 1. My dog Arlo divided by my dog Arlo is 1. If you take all of my dog Arlo and divide them up among only my dog Arlo, you're only going to have to cut them into 1 pieces, which means you don't have to cut them, which is good because I don't want you to cut my dog Arlo. And if you take a mole of iron and divide it by moles of iron, that just becomes 1. So that unit is mathematically going to disappear. Does that make sense? And mathematically, this unit isn't being divided by anything, so it's going to stay there. So as long as everything in here is true, the numbers have to work. So look at me. Moles of iron is going to cancel with moles of iron. Grams of iron is going to be left behind. We look at the units first. And then I always just say, I want to do a quick double check to make sure everything I wrote is true. Does that make sense? So quickly, does the question tell me that I have 3.46 moles of iron I'm supposed to get? Does anyone else smell?
Yeah. I smell it too. Like, it's something like burning.
Is this something burning?
It's like a bagel.
I see that.
Toasted bagel.
Can I actually do this too?
That's quietly
It's not
like that.
something that's like my
Well,
equipment or something.
brain quietly like that.
But do you smell that? I smell it out here maybe more than in there. But yeah, try out here, and I just want to confirm, as long as it's somebody else's problem, I would just hate to burn the school down. Though, since it's teacher swap day, I would totally say Wyatt did it. And then we just have to say, is this fact true? Is it true that 55.845 grams of iron is the same as 1 mole of iron? And then here's where this gets a little esoteric. And if what I'm about to say sounds confusing, just ignore me. But remember we said how if you divide something by itself, it just equals 1? Or if you divide something by the same number, right? 3 divided by 3 is just 1. 8 divided by 8 is just 1. And of course, if you multiply by 1, does the number change? No, right? If you divide by 1, does the number change? No. But here's kind of the weird thing, and this is where math meets philosophy. You'll never hear a math teacher talk about this, but this is what we're going to talk about in science. This fraction actually kind of equals 1. Not the number, right? 55.845 divided by 1 doesn't equal 1. Just give me 1 second. I promise I'll answer your hand, but I just want to get through this. But what I mean by that is, when we do dimensional analysis, all of our fractions are going to not actually change physically what we have, because 55.845 grams of iron is 1 mole of iron. Does that make sense? Those mean the same thing, which means numerically the number is going to change. But the thing we're talking about, we're actually multiplying by 1, because this is taking 55.845 grams of iron, and this is taking 1 mole of iron. The math of it is that those are 2 different numbers. But in practice, if you went and got 55.845 grams of iron, and you went and got 1 mole of iron, you've gotten the same thing. So you're dividing something by itself, all of which is to say, anytime you set up one of these fractions, the top and the bottom should be different numbers and different units that mean the exact same thing. Does that make sense? Like yesterday or 2 days ago, we did an example where we said like there's 60 seconds in 1 minute, right? Well, those mean the same thing. Or we did examples where we said that 12 eggs, we didn't say eggs, I think it was something else, but whatever, is a dozen eggs, right? Even though they're different numbers, they're the same thing. Okay, now that we've got that all set up, am I not burning the school down?
It doesn't look like it.
Okay, then I can live with that.
It just smells like burning.
Okay, and then how would I put this into my calculator? I would say, oh, what a perfect place for that. I would say 3.46, and then times 55.845, and then divided by 1. And then I would press equals, which they very cleverly put in a different place than the multiplication and division symbol, because this online, that's very smart calculator, it's very good at being a calculator thing. And what do we get? Really quickly, 3 times 55 would be 165, and then another half of 55 on top of that would be 27. I can do this. So that would be 192, and then almost another one of those would be, this should be around about 195, 196. No? Okay, that's pretty good. Oh, because that's not 0.5, that's 0.46. All right, but that was not bad, right? Just lie to me. Just say it was good. Orlando, that was really good. Oh, that was good. That was convincing. I liked it. Yes.
Why is the mole crossing?
Because they cancel. Because the whole reason we do this is that if you divide anything by itself, and remember, what a fraction means is take this, multiply it by whatever's on top, and then divide it by whatever's on the bottom. But we don't just do that with numbers. Like, yes, we're going to do 3.46 times 55.845 divided by 1. But what they don't teach you in math class, but they should, and I've been screaming at them for years that they should, is that like you also multiply the units. Moles times grams is mole grams. That's a unit. But then we have to divide it again by moles, mole grams per mole. But the thing of it is, when you multiply by something and then divide by that same thing, those actions cancel each other out, right? Because multiplying and dividing are opposite. So when you multiply by something and divide by it, these two operations cancel each other out. And so what we're left with isn't mole grams per mole, it's just grams. And if that seems too mathematical, what we can just say is if something's at the top of a fraction and the bottom, and when we multiply this, this will be at the top of the fraction, then they just cancel out. And that's the mathematical trick of this. And
Not
it
write gram instead? Why we have mole cross out?
because that's the whole way this works. So you got to follow with me, and you got to pay close attention as we do these, because at first it's going to seem like that seems like a big waste of time. But that's because we're just doing one-step calculations here. 2 weeks from now, you're going to be doing things like this where you have 9 fractions in a row. And you go, this cancels that cancels that cancels that. Yes, I've got everything lined up. And it's not going to be scary because we're going to start with small things and do it. But if you try to rush it, if you try to say, I don't need to write that for this, you'll fail miserably. You have to trust the system. All right? You got to trust me. You got to trust me that we're driving with the training wheels here, where we're showing all these steps for simple things, and it may seem like a waste of time. And if you don't understand the math of it, that's okay. You don't have to understand the math of it, because you can do it as long as you follow the system, but you have to trust the system, because if you try to cheat it here when it's easy, in 2 weeks when we're doing things that are 7 steps, you're going to be screwed. All right? So I know that probably you could just say, can I just multiply these? I know that that's how much a mole weighs, and I know that we have 3.46 moles, so I'll just multiply them. I know you can do that, and I know you're smart enough that a lot of you have enough mathematical intuition to just say, I'm just going to multiply the two. Don't. Write it out and follow the system here, because what's going to happen is it's going to help us when we get to things that I promise you won't be able to do in your head. Because there's lots of stuff in this class I can't do in my head. And I'm pretty good at math in my head, though not good enough to get the right answers. But good enough to, like, you know, if I had drawn because I actually said 8, if I had scribbled my 8, it would look like that 3, and then I would have looked like I got it. So the answer, am I going to keep all these decimals? We haven't done our day on rounding yet. But long story short, how many digits do I have here? Yeah, so I'm just going to use the first 3 digits here, which also happens to land nicely because then I have no decimal. I'm happy with that. So my answer is going to be 193. And then what is that 193? Well, the whole reason we did this is we decided to stop talking about moles and start talking about grams of iron. So it's 193 grams of iron. And we're going to do about 3,000 more examples of this, which is how many you need to do, because you will have this good enough when your instinct, when anything comes up in life, is to do dimensional analysis. My kids come to me and say, hey, can I have the car for the weekend? And I just go like, Greg, I have one Greg, and I don't want to talk about Gregs anymore. I want to talk about my car. And one Greg wants to use one of my cars. And then like, oh, I don't want to talk about cars. I want to ask, do I work? ? We have one car and I don't, like whatever. Just, I'm joking. But the point being, inevitably what will happen is this will take over your life, because you'll discover that half the stuff you do in math class, you can just do it better this way. And like half the stuff you do in physics class, you can just do it better this way. And like any math they have you doing in shop class, you can just do it better this way. So that will be the point when I know I've won you with this. I remember I didn't learn this in high school. In high school, I learned everything by equations. And if you really struggle with this, I will show you the equations. But for 99% of people, they prefer this to doing big algebra, where we get to equations like, V2 equals, V1t plus 1/2 at squared. And it's like, oh, we want to solve for t, do it algebraically. Most people would rather intuit it and talk their way through it like this. So that's how I'm going to teach it. Trust me. Okay, let's try another one. We've got helium. How much helium gas do we have here? Oh no, scientific notation. Hey guys, normally I would say let's do this as scientific notation on our calculator, but just for this one, let's see, can we turn this into a normal decimal just to make working with this easier? We have 4, 8, and 6, and the decimals here. Is this going to be a bigger number or a smaller number? Great. How much smaller? How much do I move the decimal? Twice. And to make it smaller, I'd go this way. So there's a decimal blank 486. So that's decimal 486, and we can go from there. I think it is. I just wrote down. There's a decimal, and then there's a 4, and then there's an 8, there's a 6. What's going on here? Oh, you're right. Okay. In blank spaces, what do we put? Zeros. Okay. And what is that? That's moles of helium. So moles of, I just put Fe, but what's Fe? Iron. So we're going to start with moles of helium instead. So we're going to start with 0.0486 moles of helium. By the way, you can totally do this with the scientific notation, but I find when we're just learning this stuff to start, it's kind of nice if we don't put two things in at once. And the question is, how much does that weigh? Now again, you may be looking going, can't just multiply this by how much? And yeah, but we're going to stick with the system here. What I want you to do every time is you're going to write down what we're given. In this case, we are given 4.86 moles of helium gas. And then what do I want you to do without thinking? Do not think about this. Times a fraction line. No thinking. Just do it. Just put that on the page. Then what do I not want you to think about next? Yeah. Oh, sorry. You're way ahead of me. I don't want you to think about numbers. I want you to think about units. And you're right. The unit we don't want to think about anymore. The question doesn't ask for moles. It gives us moles. It asks for mass. So we want to not think about moles. If I want to not think about moles anymore, where do I put that? On the bottom, right? And again, there's no numbers yet. We're not doing math yet. We're talking ourselves through what we're doing. What unit do I want? It just says mass. But we are chemists and we measure mass in, you've like rolled your, can you do that again? Oh, that was lovely. I cannot do that. I have tried. People have tried to teach me to roll my R, but I had a speech impediment and I couldn't even make a regular R sound until I was 11. I could only make an L sound. So any word with an R, I would just replace that sound with an L. So like glams, for example, or like my name was Joseph Orlando with no R in it. And ironically, which would have been ironically for me, I gave all of my kids R names. I have Claire, Gregory, Charlie. And it's funny that I didn't plan that. Those are just names we end up liking. But like, those were names. When you were in elementary school, did they still, if you were reading a book, just make you go around the class and it'd be like, you read a paragraph and they just went in order? Did they do that? They used to do that. That was like such a thing for us. And I remember I would be looking ahead, and at the paragraph I had, I'd be looking at all the R words, and I would be writing on my page words I could substitute for them that I could get away with, right? So if there was a name like racing, I'd be like, shoot, what am I going to say? Speeding, right? And if there's a word like, I think this is part of why I love words so much and talk about words so much, because I used to sit there and try to, in advance, figure out like how I could avoid those words because I just couldn't say them. I also struggled with like S's and THs, but the R's were the really embarrassing ones. I used to get picked on pretty badly for it. Well, yeah, this is what people say. But anyway, and I think that's where my like kind of love of words comes from. But if you had told my 9-year-old self who was like, who would like go in the bathroom and cry because people would make fun of the way he said the letter R, that I would have given all 3 of my kids words with R's in their names with R's like up front and center, I would not have believed you. Anyway, that's neither here nor there. This is why I'm such a good teacher, because I'm so focused all the time. So we have 0.0486 moles of helium, and we say, I don't want to talk about moles, I want to talk about grams. And the reason we do this in the fraction is because mathematically, if we take something and divide it away, it goes away, which means moles is going to go away, and that's going to leave us with the unit grams. And mathematically, that's what I want, because I want my answer to be in grams. And we don't just write units at the end. We do math with units. All right? Scientists do math with units. If I multiply moles by grams, that's a gram mole. If I multiply moles by itself, that's a mole squared. But if I take moles and divide it by moles, well, now that unit's gone. And there is no unit. But then I put another unit in there, grams. Yeah?
With the 0.04, what at the top under the helium gas, what is going on with the period? Where is it?
It was between the 4 and the 8. And the scientific notation tells us that we have to move it how many times?
Okay.
2. Yep, that's all we did there.
Because I had to move some of my notes.
No worries. Let me, here, I'll do that in a different color, a lighter color. It was here, and we're going to take it and move it once and twice, which puts it there. Is that better?
Yeah.
Great. And please, if it's ever hard to read up here. So now our setup is good. We will cancel moles and talk about grams, but we have to be able to put a true fact here. We have to know how many moles are in a gram of helium or how many grams are in a mole of helium. We need numbers here. And luckily I have a periodic table, right? And I can look and say 4.00, perfect. So 4.00 and 1, and then I'm good to go. And that's right, of course, because I'm the teacher, and I'm going to sip my coffee. No, it's correct. It's correct. Let's move on. It's correct. I think it's correct. I'm pretty sure I got it right. Look at you sheeple, just blindly writing down what I put on the board. If I put up here like, Mr. Orlando is so smart, I bet you all just wrote that in your books.
No.
I bet if I said, my bank number is,
Yeah, thank you.
and then just paused, I bet you would all just finish that off. And I'd say, okay, now hand your quizzes in. I'm going shopping, baby. Anyway, yeah, what's wrong with this? And here's what I want to say. The beautiful thing about dimensional analysis is, okay, I set this up, I'm good to go. But before I do any math, I always say it out loud. And I say, okay, I have 0.486 moles of helium, but I don't want to talk about helium. So I'm going to cancel helium and talk about grams instead. And I know that 1 gram of helium is 4 moles. And as soon as you say that, if it doesn't bump now, it will really shortly. It will be like, wait a minute, that can't be true, because the lightest thing on the periodic table is helium, and that's 1 gram per 1 mole. So those numbers don't make sense. And again, that might not be happening to you yet, but like if you're doing an equivalent example, if we said like, okay, I want to know how many seconds are in 32 minutes, and no worries, I'm going to cancel minutes, and instead we're going to talk seconds, and I'm good because I know that, and so I don't want to talk about minutes, I want to talk about seconds, and I know that 1 second is 60 minutes long. With that one, because you're comfortable with this, you're all like, wait a minute, that doesn't make sense. That's not true. What would make it true? 60 seconds is 1 minute.
Usually, the thing that's getting canceled out is usually the one.
Yeah, now that won't always be true, and we're going to get there. But you're right. That's what we've been used to so far, for sure. Absolutely. But it's not always going to be true. But yeah, we know that 1 mole, because that's what the periodic table tells us. The periodic table does not know what your question is. Does that make sense? So when you get a number off the periodic table, it's always based on how many moles? 1. Nobody went to the writer of Science Kit and Boreal Laboratories and told them on October, what's today?
27.
On October 27th, 2023, Victoria's going to be sitting in chemistry class, and the question is going to be about 0.0486 moles. So you better print that periodic table so it tells us how many grams are in 0.0486 moles, right? Nope. What the periodic table always tells us is how much 1 mole weighs. And for helium, it says that 1 mole of helium weighs 4.00 grams. And now we'll say it out loud again, just to make sure we got it. 0.0486 moles of helium. I don't want to talk about moles. I'm going to put it on the bottom so they cancel. Instead, we'll talk about grams. And I know that 1 mole of helium weighs 4 grams. Does that all check out? Let's do the math. And what will I do with the math? I'll take this number and times it by 4, and then
Divided by 1.
divide it by 1. You guys are going to do that on your calculator. I'm going to see if I can do it here.
Which
4
is-
times 4, 1 sec. 4 times 4 is 16. So that would be 0.16. But then 4 times 8 is 32, which would make that. And then 4 times 6 is 24, which would make it that. So this should be 0.1944.
World War II.
How'd I do?
You got
Yeah,
it.
yeah.
Now I should be able to do that in my head. And you know, I wrote it down here. I wanted to act like I was doing that for your benefit, but really I'm doing it because my mind is really sludgy today and I just could not keep track of those numbers in my head. But I'm still feeling pretty good. And how many like actual digits do we have here? A 4, an 8, and a 6, a 3, right? That 0 is just a placeholder. So I think I'm going to go with 3 digits here. We'll drop that 4. I'm going to go 0.194, but if you put 4, that's fine. And it's grams of helium. All right. I want you to try the next one. How many moles are there in 17 grams of calcium? And if you take a note, you're going to notice that this is not the same question we've just been doing. What's different about it?
It's kind of like switched around.
It's switched around. Here, we've done things a little differently. Here, we've got the benchtop number. You went to the scale and weighed it, and you said, okay, I weighed this out, and I've got 17 grams. Now I want to go in my book and figure the equation out, right? The problem is we do chemistry on the bench in grams, but when we go into our books to figure out equations and stuff, we always do that in moles. You're going to have to go the other way here, which is why this lesson is called Moles to Mass, which we just did, and back again, A Chemist's Journey. That's a pun. Well, it's not really, I guess it's a pun. Has anyone read The Hobbit? You should all read The Hobbit. It's really good. Has anyone read Lord of the Rings? Has anyone seen Lord of the Rings? You should watch those movies. They're really good. You've seen them? Those are great movies, right? These people are mutants because they haven't seen them, right? You can say it. You can say why it's a mutant. Look at me.
Yeah.
Is White a mutant?
Yes.
Cool. What about Mental Kamakai? Bit of a mutant? Yeah. Hannah High?
I think.
Hannah High, is Hannah High a mutant?
If you say my name,
Yeah.
I'll punch you.
Is Victoria a mutant?
You
She's
say-
sitting to punch me, not you, so it's good.
I mean both of you.
I'll
At the
just-
same time?
Yes.
Who gets the left hand? Who gets the right hand?
Both. Matter of fact, I'm electric.
I'm electric. I'm electric. Actually, I'm elastic and electric. I'm an electric elastic girl. I'm going to punch you both for calling me a mutant. Here I am recording my lesson where I call all my students mutants. Yes.
What movie?
Lord of the Rings. It's a trilogy. They're great. They're also a book, and I used to read these books. They're like thousands of pages, but they're really great. I will say they're really like dense. They're kind of it's a different kind of writing. They're written in like the 30s and in the 40s and 50s, so it feels kind of slaggish to like modern ears, but they're wonderful. They're brilliant. But anyway, The Hobbit was written first, and it's kind of like a
Oh, mine's
prequel.
away.
But The Lord of the Rings starts with its lead character actually writing the book The Hobbit, though in the book Lord of the Rings and in the movie Lord of the Rings, he doesn't call his book The Hobbit. He calls it There and Back Again, A Hobbit's Journey. So this is moles to mass and back. What I'm saying is I'm a big nerd, okay? I'm a big nerd, but now you got it, so that's fine. We'll move on. What we will do is I want you to tell me that if I had you go weigh out 17 grams of calcium, how many moles of calcium have you just weighed out? You're doing exactly what we did here, but it's going to be a little different. I want you to try it. You'll either get it right or you'll get it wrong, and that's fine. I don't care one bit because then we're going to take it up. But if I come back and you haven't tried it and your page is blank, well, then I'm going to get Elastigirl over here to punch you with both her hands. All right, try it. Give it a try.
Okay.
The worst thing you can be is wrong. Don't show me. Don't show me.
Really? Not.
Because I don't want you to. And I'm going to say it's so close to perfect, but when you read it out loud, you're going to say, oh, there's something in there that doesn't make sense. That's all.
Yep.
Orlando.
Yep.
I don't understand this at all.
Well, what I want you to do is
Okay.
the system, which is the system.
Understand the system.
That's it. Well, I know. So I'm going back. Going back. So the system is this. What we do every time is we say, okay, they've given me something. They gave me a starting number with a starting unit. Right? So I'm going to write that. That's the first thing I do. Then I'm going to multiply it by a fraction line. I'm not going to think about it. This isn't some like, ooh, I'm going to understand why. No, just do it. Right? If they gave you 11 dogs, you'd write 11 dogs, then you'd write a multiplication sign in that line. Don't think about it. Just do it. Right? This isn't thinky think time. Right? Because when you get in your car, I don't want you thinking on the road, driving on the road, stay straight in the lane, driving on the road, stay straight in the lane, car coming, don't hit the car, stay straight in the lane. That's not a good driver. A good driver is somebody who's done it enough times that they just do it. They just do it, and there's no thought involved. We want to save thinking for like big concept-y stuff. We want math to just be doing. And the way we do that's repetition. So whatever the number you're starting with, and this is why you got to bear with me. It's why you got to do every example, because you want to understand it first. Let me tell you a little secret. Very rarely in life do we understand first. Usually what happens in life is we learn how to do something by rote first. We just repeat, and we learn how to do it. And then years later you go, oh, that's why that works? Cool. They're not going to teach you to drive by teaching you how a rack and pinion steering system works and how regenerative braking works and all that. They're just going to say, this is where your foot goes, push it. And this is where your hands go, turn them. Does that make sense? I know, so I'm telling you where your foot goes. So you're going to write down the number that you've been given and its unit. There's only one number here. What is it? Okay, good. Write down. Write down. Physically. And then put the unit next to it. And then put a multiplication sign and draw a line. And by the way, I'm not like, this is hard. This is like learning to drive. Has anyone learned to drive yet? It's hard. Man, you're learning to drive? Oh no? Oh, good. That's what you want to hear. Listen, overconfidence is the bane. No, listen, trust me, I've watched people learn to drive, and, it's hard at first. It's weird. You don't know where your car is. You think you know where your car is, and all of a sudden you're hearing the rumble strip, and you're like, why am I hearing the rumble strip? I'm perfectly centered in the lane, but no, you're not. Or you watch, like you tell somebody who's a new driver to check their blind spot, and they look to the left and the whole car goes left, and they have no idea they're doing it. And then they look to the right, and the whole car goes right. And so then by the time they look center again, the car's in the middle of the lane, and they have no idea that they've just gone like, whoa! And everyone in the car has been like, oh my God, are we about to go into traffic? And they have no idea, because they've just been checking their blind spots. This will feel like that. Yeah. So we start just by writing, what's the number? 17. What's the unit? Grams. And then you could go with just this, but my advice is always, don't just say grams, tell me what it is. So we're going to say 17 grams of calcium. And then we're going to multiply it by a fraction. And then we're not going to think about numbers. No numbers for a second. No numbers. Because the next thing in the system is that we don't think about numbers. Instead, we work with the units. And what we do is we always put the starting unit right back on the bottom, because we don't want to talk about that. We need to cancel it out. So whatever unit you just wrote down, you're going to write the exact same friggin' unit again. And where are you going to put it? Where do we put it? At the bottom. We don't think. We just do it. We say, okay, I don't want to talk about grams of calcium. All of this happens with zero thought. We have not thought yet. This is just repetition. We just do it. Just now, for the first time, we have to think a little bit. And all we have to think is what unit goes on top. And that's just a question. What is the question asking me to tell them? And in this case, what are they asking me to tell them? Moles. So that's what's going to go on top. By the way, I'm not stupid. I'm not going to write 4 letters, M-O-L-E. I'm going to short form this bad boy to M-O-L. So much more efficient. And of course, what are we talking about? Calcium. That's the first thinking we did. And it's not a lot of thinking. And then I always say grams is going to cancel with grams. I always cross it out to remind myself that I've done my job. I've stopped talking about grams. I've started talking about moles. But this will only work if we put a true number in here. We have to know a fact. Not about our question. We're not talking about 17 grams here. We have to know, like, in the world of facts. If we're doing conversions, this would be the kind of place where we'd say, 60 seconds is 1 minute. Or, 360 degrees is 1 full turn. Or 12 is 1 dozen. This is where just a basic fact goes. The problem is this is a basic fact about chemistry. Where would we look for a basic fact about chemistry? And Mental Kai is looking there. Where do we find our basic facts about chemistry? On the periodic table. So see if you can fill this in. See if you can find on the periodic table how many grams are in a mole of calcium or how many moles are in a gram of calcium, wherever we get that information. I'm going to give you 2 more minutes, and we'll take it up. But that's our basic setup. And again, please don't feel discouraged at all. I'm not trying at all to be condescending. Things feel weird. I always think about learning a song on the guitar. Anytime I learn a new chord, my hands always feel very strange. And what I practice is just taking it off and putting it back on, taking it off and putting it on, taking it off and putting it on. And then I practice talking to my wife while doing that. My wife loves this because she always loves having a conversation with somebody who's playing the same chord on the guitar over and over and over again for 10 minutes. And she goes, "This is really nice. Please keep playing your guitar, Joe. It's helping me concentrate on the conversation at hand." But I try to see if I can do it without thinking about it. And the great thing about the conversation is that at first I really can't. So I'm like, "Yeah, Britt, so today at school I was, blah, blah," right? And she loves those stilted conversations where I fade in and out all the time. It's good. Yeah, get a hand up.
Are we writing anything else or just this?
Well, now you have to put the numbers in, and then you're going to do the math. So now you actually take your calculator, and the math is as simple as the units we've already done, right? Grams cancels with grams, so the only unit left is the moles of calcium. If they didn't cancel, we'd have to write all the units down, but we only have one left. And then to get the number, well, you take this number, and that tells you, what do we do with it? We multiply it, and then a fraction means to do what with it? Divide. And this is so important. We're putting our big boy pants on. We no longer do 17 times whatever this is equals, then take that number and divide by that, and then press equals. Big boy time, big girl time, big person time. We do it all at once. And I'm not saying that to be condescending. You will just save so many errors, because when we get to one of these that is 8 fractions long, you don't want to be writing down 18 steps. You just do it in one. You just do it in one. I trust you. Yeah. So take a minute and oh, that went terribly. I almost dribbled that all over myself, but I saved myself at the last possible second. So
Is there no backspace button on this?
I think you have to press the back arrow and then just right over top of it. But they're pretty crappy. I mean, they're not crappy. They're very expensive calculators. But there's things about them I very much do not like.
How many do you have?
16. Which is a downgrade. At one point I had 32.
Slap me a guitar.
Sorry?
Slap me a guitar.
If you listen, anytime, if anyone ever wants to borrow a guitar and take home and learn, just talk to me. I'll lend you a guitar to take home and learn. There's nothing I love more than people learning guitar. Seriously.
Let's not do
No.
that. Let's not do that.
No, that's this one. And I sold a car to buy this guy when I was in my first year of university. It's my first child. And she's not, I've been struggling with her. She's not in the best of shape anymore. And I don't know, Mr. Lastrak thinks maybe one of the bracings has come loose. You can see it has cracks in it. I lent it to my cousin Mike, and it got, I don't know if he did or I did. One of us did. It didn't matter, because it's my fault anyway, because it's supposed to have a humidifier in it. So there's a thing you put in here that no matter what keeps it in the proper humidity, because this is very thin wood. And unfortunately, it dried out. And so the top cracked, which doesn't affect its playability, but it affects its value, which doesn't matter because I would never sell it, right? Like this been in my life a long time. But it also affects its, you just have to keep maintaining it, because I have to treat these every few years to make sure they don't spread. And they had spread a little bit, but not bad. But now I have a rattle. If you listen, normally you can almost play the guitar like a drum, which is really like a thing guitarists do a lot, right? So you'll be like playing it, so you'll be like. Yeah. But now it's got this, hear how it kind of rattles? It's almost like a snare drum, which is A, annoying, but B, that rattle happens, certain notes bring it out. So like now when I play a chord, if you listen, it's got almost like a fuzzy sound to it. And that's that same rattle joining the sound. It's just got a little bit of fuzz to it. Almost like a speaker that's being played too hard. Just a little.
I like it though.
Well, I can't, it's making me feel crazed. But this is a quite nice guitar. This is a Martin D28. Martin is one of the older guitar companies in the world. And they build all their guitars by hand in Nazareth, Pennsylvania, where you can go and they have like a big museum of like thousands of guitars over the years. But like all of like, I'm like a folky guy and I love like my, Bob Dylan and I love my Paul Simon and, Paul McCartney and John Lennon. And these were like the guitars they played. Like Blackbird was played on a D28.
There's these like TikToks or Instagram videos where you see these guitar men or motorcycle men, right? Everyone loves them and all that. I plan to do both at the same time.
I suppose that I will tell you my experience, which is being a guitar man did not seem to make anybody love me, but I still enjoy playing the guitar. A few years ago, we were talking about making like, should I tell this story? Oh God, I'm recording right now. Well, whatever, I'm just going to say it. We were talking about like putting posters up to like encourage people to take like math classes and stuff. So Calford had designed these posters, and I thought they were kind of like a little cheesy. So I jokingly made up a bunch. And so I started putting them in his room, and they started out being fairly mild, where it would be like math, and that would say like English but useful, right? Which I thought was funny. And then I made one, and again I was trying to be like as if Calford was putting these up, right? And I was saying math, and it would say like It's like art class, but nobody will ever pay you to do it. Which I thought was pretty funny. And then I did one, and I realized I'd crossed a line where it was like math. It's like sports, but nobody wants to make out with you if you're good at it. And I thought that was funny, but Kelford thought it was inappropriate. Anyway, that's the end of my story. Moving on. What numbers go here?
One on the bottom. I mean, one on the top.
Yeah, one on the top, because 1 mole is what the periodic table always tells us. Whenever we look at the periodic table, it's going to tell us how much 1 mole is. How much is a mole of calcium?
40.078 grams.
Very good, 40.078. And there we go. And so this is going to be less than 0.5, but more than 0.25, close to 0.5. This is going to be like what, 0.4 something, 0.3941, somewhere in that range? 424. Okay. Perfect. And that means if I told you to go weigh out 17 grams of calcium, and you did, and then we went and sat down and wanted to do some chemistry and actually figure a recipe out, you'd weigh this out, but this is the number you'd use to do the chemistry on paper. Does that make sense? Because this is a counting number, and this is a mass. All right, we're going to try one more together, then we'll be done for the day, and you're going to finish the last couple of these for homework or practice or whatever during English class, because again, we don't. Here we're going to have to use scientific notation, by the way, because this is a tiny number. Tiny, tiny, tiny number. That's okay. But when we go do this question, grams of carbon dioxide, okay, perfect. We know what carbon dioxide is. What's the formula for that? CO2. Okay, perfect. Great, we got that. So, and what are we starting with here? What's our first number? Well, it's scientific notation, but that's fine. We can work with scientific notation. 3.42 times 10 to the negative 11. Is that a really big number or a really small number? Yeah, I do not have a scale that could weigh that out. That would be a scale that has to have at least 11 decimal places. My most expensive scale, which costs like $2,000, only has 4 decimal places. So this, not going to happen. But that's okay. And what's the unit? That's grams of CO2. Okay. And we would say, no problem. I don't want to talk about grams. Where do I put it? On the bottom. Am I thinking yet, by the way? Not really. What do I want to talk about? Not grams. I want to talk about moles. And why do I want to talk about moles? Well, because somebody asked me about it. And I always talk about what people ask me to talk about. Moles of CO2. And we go, great. And then I know I'm going to look on the periodic table, right? And the periodic table always tells me how much, what weighs? How many moles does the periodic table always talk about?
1 mole.
Yeah, the periodic table always talks about 1 mole. And now, I'm just going to look for CO2 on here. HELIBEDCNOFNENAMGAL. I'm looking, I'm not seeing CO2. That's the problem. Yeah, because it's a compound. It's a molecule. It's put together. So this is where 2 lessons come together. Before I can fill this in, I just have to quickly say, oh, wait a minute, how much does CO2 weigh? And that's trivial, right? Remember we did that? Because it's just going to be however much carbon weighs, right? And then it's also going to be, how many oxygens does this have?
11.
So I have to multiply it by 2, right? And just say that twice the mass of oxygen. How much does carbon weigh? 12.01 grams per mole. And we can just work with 2 decimal places here. That's fine. And then plus 2 times, and how much does oxygen weigh? 16.00 grams per mole. And we can just do that math. And do that in your calculator. 2 times 16 is 32. So this should be 44.01 grams per mole. But can somebody check that for me?
Yeah.
Is that right?
Yeah, but I had another decimal.
Yeah, if you have more decimals, it may be 0079 or whatever.
I just got 44.01.
That's fine.
I can't read the first line then. 12.01 what?
Oh, sure. Grams per mole. Because that's how we're going to read the periodic table from now on. When we read the periodic table, we're going to read it like practical bench chemists. And practical bench chemists look at the periodic table, and they use it to tell them how many grams they're going to have to weigh out for every mole they have to work with. Now, the other way you can read the periodic table is you could say that carbon weighs 12 atomic mass units. But that's not what we care about. Does that make sense? So from now on, we're going to think of the periodic table as telling us how many grams are in a mole of this stuff. And now, I'm ready for this. Now I know a mole of CO2 weighs how much?
44.011.
Yeah, and I'm just going to do a 1 because I didn't use as many decimal places as you do, but that's fine. And we can just do this on a second line. How do I actually do the math?
Okay. On your calculator.
Yeah, because we got to be careful with this one, right? Because it's got some scientific notation in it. Spooky. But we'll do it together here. It actually looks basically the same. First, you just got to put the numbers in, right? So that's easy. The number is 3.42. And then should I multiply by 10?
No, you put second and then
Yeah. For you guys, you're pressing second function comma. For me, I'm pressing Shift E. But what we should both see on our calculator is a big uppercase E. Try that right now. Make sure everyone does it. Don't wait for someone else to do it. And then what goes in? Now do I put 10 to the negative 11? Yeah, you have to press the negative sign, which for you guys is a bracket, negative, and then 11, right? That's what you should see on your screen. 3.42 times 10 to e to the negative 11 means 3.42 times 10 to the negative 11. Oh, I'm going to do this one in my head. Give me a second. But I'll probably screw it up. But if you're okay with me screwing it up, I will do it in my head. And then we're multiplying it by, I can do the next part easy, that's for sure. What am I multiplying it by? Okay, if we stopped there, it'd be 3.42 times 10 to the negative 11. Wow! He's so good. But now we have to do what? Divide it by? And we're going to divide it by 44.01. By the way, ready? I think I can do this. Dividing by 10 would make it to the negative 10. So we're going to be 10 to the negative 10. But then we're going to be to the negative 9 as well, because there, and 34 divided by 44, I mean, we're going to be in the range of like 8-ish times 10 to the negative 9.
Yeah.
All right? And when you do this on your calculator, it's probably going to answer with an E, right? My calculator, one note is great, but it doesn't like anything below negative 8. So it's actually lying to me. It's just like, nah, I can't do that. What does your calculator give you? It probably gives you, was it 8 point?
So I got 7.77.
Okay, yeah, 7707, and then there's an E, I bet.
Yeah, E.
And then it's negative 9.
No.
Negative 8?
13.
Yeah, 13.
Oh, I went the wrong way. Oh, I'm so stupid. I was dividing, not multiplying. Oh, I'm dumb. Yeah, negative 13. Okay, now, can we write our answer like that?
No.
No, because what does that E symbolize? That's the calculator's way of saying.
Scientific notation.
Yeah, it's the calculator's version of times 10 to the exponent negative 13.
So
And when we write it, we're going to write it that way. So the answer will be, and do we need to keep all those decimal places? Now, how many did I have here?
3.
Yeah, so I'm going to keep 7.77. For now, until we do our day on what we call significant digits, you can just kind of pick. Be reasonable. If you're not sure, ask me. And then times 10 to the negative 13. And then what's the unit? What unit's canceled? Look up here. What unit did we get rid of? Yeah, we said I don't want to talk about grams. What unit are we talking about? Moles of CO2. All right? And that's the game. That's the whole thing. We're going to do this for a bunch of days. If this feels like, what am I doing? We're going to do it for a bunch of days. But listen to me. You got to trust the system. You have to practice. And when you practice, you can't take shortcuts. You got to write it out in full, even if it feels like that's a waste of time. I know how to do this without writing it in full. Because, again, you may know how to write it out in full now, but you know when you're not going to know how to write it out in full? Or sorry, you're not going to be able to do it in your head when they get tricky. And they will get tricky. And they won't be tricky if you trust the system. If you trust the system, you'll be like, this is just longer, but it's not harder.
Unless you're Matilda and you're a calculator.
I am Matilda.
No, you
You guys just don't know it.
Hannah, hi. I know it. Hey, Hannah, hi. Do you have a minute?
that.